Okay, so if I were to plug in, and I use that term loosely, what do I get? Right, if I take the natural log of really big, I still get infinity, right?
Yeah.
Here I get infinity. So I have an indeterminate form of infinity over infinity. So equals, put a little h for L'Hopital's, limit, x goes to infinity. What's the derivative of the top?
1 over x.
1 over x. Derivative of the bottom, that's really 2x to the 1/2.
Yeah.
So when I take a derivative, I'm going to get 1x negative 1/2.
Yeah.
1 over square root of x. Yes?
Mm-hmm.
Which then I can KFC. Now there's no need to put an h over because you didn't take L'Hopital's rule. You didn't do another derivative. 1x times square root of x over 1.
Yeah.
Now a lot of people go, well, I can do it again. I don't need to. Isn't that just x to the 1/2?
Yes.
And you're dividing? Yeah, this is really x to the 1/2 over x to the 1. You subtract those powers. You get x to the negative 1/2.
Yeah.
Which is really 1 over square root of x. Does everyone follow that?
Yeah.
Little division there. That's what transitions is doing right now. Okay. Now, plug in. Can I plug in infinity now?
Yes.
Yes. What do I get?
Would it be negative infinity? No.
Guys, you've forgotten all of chapter 2. The bottom is getting bigger and bigger and bigger. What's the whole thing going to?
Infinity.
Really? Because I think that's getting real small.
0.
That's 0. If you can't remember these rules, we're in trouble. We're in trouble. As you get closer to 0, we're assuming a constant on top. You get closer to 0 on the bottom, you're going to infinity. You get closer to infinity on the bottom, you approach infinity on the bottom, you're going towards 0. So as that bottom gets bigger and bigger and bigger, the whole number is getting smaller and smaller and smaller. Yes? And you can plug in because 1 over infinity is not an indeterminate form. It's 0. Questions?